Before jumping into a regression analysis, we need to make sure a regression analysis is really appropriate for our data. Thus, we should check a couple of assumptions which are really insightfully easy and straightforward. The first one, actually, as you can see, there's no point because it's too easy, too basic for us. However, it's important. So what are the predictors and what are the outcomes? We already talked about this, right? And then the dependent variable was a statistic test scores. And then what is our predictors or deep independent variable? It was like quantitative test scores and study hours. And then what is the variable type? For linear regression, the outcome should be continuous. The statistics test score is a continuous. Yeah, it's not categorical like good score or bad score. Not like this. It is more like continuum of scores. So yes, checked. So our predictors either continuous or dichotomous. So our predictors quantitative test scores and study hours. It's also as a it's also coded as a continuum. So yes, as a continuous both and non-zero variance. Um, do predictors not have zero variance? If you look at over here, so if the outcomes are have zero variance, what does that mean? It should look like this, right? The variance means like how they are varied, how their scores are varied. If there is some variance, the data point look like this. This is variance, right? If all the scores are in the one constant, have all those data point has a single constant values like this, then there's no variation, right? Then we could say zero variance. This one, we could see some variation in data point, right? So we could say none, zero variance. So coming back to the questions. So do predictors not have zero variance? No. Um, the predictors do not have zero variance. Checked, right? And then linearity. Is the relationship we model is linear? But important thing is in reality. For instance, let's say like um age and height. Yes, some extent if we grow up, like older adults obviously has higher height, but to some extent it could be a little bit decreased because of the aging. So we could say it's not linear. Or what about the happiness and income? If income, as income increase, happiness would increase, but some point it could be reached at plateau. Or like the other IQ and test scores could be like that as well. So if some relationship is quadratic in reality, then we may not fit the linear regressions. And then the last one is independence. So do all values of the outcome come from a different person? Yeah, in our case, every single cases are different from different person. So yes, checked, right? However, for instance, the repeated measure. Let's think about the repeated measure ANOVA. For instance, one person was repeatedly measured. Um, for instance, we take some medicine today, and then check the blood pressure. And then we take some other medicines 1 week after, and then check the blood pressures. And then we repeatedly measure blood pressures for 6 months. And then all those scores actually are not independent, rather it's dependent each other because it's from one single person. Or one person take the multiple exams like math and then science and then writings, and then all those scores are from the one person, right? And then, or there's tons of cases that the scores would have dependency between each other, among each other. So in that case, we may not use the linear regression for those data. But in our data, yes, all those scores are from the same person. So checked. So this is really easy and straightforward assumptions for a linear regressions, and then all those four assumptions are met. So that means it is appropriate to apply a linear regression analysis in our data.